Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics. This was a new multiple choice correct type question from the topic of capacitors. The question was fairly simple and I believe most of the students would have gotten this right. But yes, interestingly, when IT released their first key, then they got this wrong. So we will see what answer was given by IIT in their first release, but eventually they gave the correct answer. We will also see the possible logic. Why did they give the wrong answer in the first place? So lots of interesting thing coming up in this video, guys. A circuit has been given to us. So this is the circuit which was also given in the exam. And you can see that here C1, C2, C3, C4, there are four capacitors over here and some 5 volt, 10 volt battery and some resistors. Okay. There are two switches, S1 and S2, initially both of them are open. Okay. Now the key is, let's do option number B first. Okay, where S1 is being closed first, let's do them first. If key S1 is kept closed for a long time such that capacitors are fully charged, the voltage across capacitor C1 will be 4 volt. Okay, so if this is closed, suppose we close this and S2 is still open, so there is no meaning of this capacitor, resistor and battery. They are still out of the circuit. So we just have to look on this part. So yes, C4, let's also mark the values. C1 and C2 are 10 and 30, C3, C4, 80. So this is 10 microfarad. C2 was 30. This is 30 microfarad and this is 80 and this is also 80 microfarad, right? Yeah. Now, if you see these three capacitors, they will be in series because in the long time there will be no current flowing through the resistors. So we can say that these three capacitors, they will become fully charged and they will be simply in series. You just have to look at the outer rectangle. So 80 and 80 will become 40 and 40 and 10 will become 40 into 10 divided by 40 plus 10, which is 50. And hence this becomes 8 microfarad. So C current becomes 8 microfarad. There is only one battery of this 5 volt. We have to ignore the resistor for now. So the charge that each capacitor is going to get will be 8 into 5. That will be 40 microcoulombs. So let's see if 5 volt battery polarity is like this. So here this positive charge will come. This will be plus 40 microfarad and this will be minus 40. So I'll be writing just plus wala charge. Other bit will be having negative. So it's plus 40. So this is minus. So again this will be plus. This is minus. So again this will be plus and this will be minus. Right. So these are the charges initially. Okay, when S1 was closed for a long time. So we have to find the voltage difference across the C1. So 40 by 10, the Q by C is the voltage. So 40 by 10 is 4 volts. So option B is correct. Okay. At time t equals to 0, the switch S1 is closed. So still we are talking about S1 only. The instantaneous current in the closed circuit. So when the switch was closed, when this switch was closed, at that time all the capacitors must have been discharged. There was no charge. So can we say that there is no current here? So we can basically replace this by a simple wire. At t equals to 0, capacitor can be shorted. So all the capacitors will be shorted. Still there is nothing happening over here. We just have to look at this rectangle, outer rectangle, and all the capacitors can be shorted. So basically we have a single battery of 5 volt and there are 70, 130, 3 resistors. So can we say that I will be is equals to 5 upon 70 plus 100 plus 30, so which will be equals to 5 upon 200, which is nothing but how much, 25 milliampere. This is 25 milliampere only. So we can say that option C is also right. Okay, now let's talk about, so actually IIT had given ABC in their first key, but eventually they made it only PC. So we will see why IIT might have given A as the correct answer and why is it wrong. Now, if S1 is kept for close for a long time, the voltage difference between P and Q will be 10 volts. So let's see if this is correct. P and Q. So we have to talk about the potential difference between this point and this point. So if we start from here, let's say we start from here VP, we are going to a drop. So 440 by 10. So drop of P and Q, right? So drop of this will be 4 volts. Okay. So and then there will be no drop over here because there is no current flowing over here, and then this will be equals to VQ, right? So VP minus VQ will be 4 volts, and given they have 10 volts. So of course this is wrong. So option D is wrong. Sorry, my bad. So VP minus VQ is 4 volts, right? So this is the wrong option. Now, if you go to option A says the key S1 is kept closed for a long time such that capacitors are fully charged. Now key S2 is closed at this time. The instantaneous current across these 30 ohms is zero point 0.2 amperes. Okay. First, let us see interestingly why or how you might get zero point 0.2 and why, like, what possibly might have prompted I2 to give the correct this as correct option. But I believe that would have been a careless error from on their part, because eventually they made it right. So if you assume potential difference across PQ to remain constant, okay, suppose we close this now. So if you close this, potential difference across PQ, if we assume it to be constant, so basically 4 volt is the potential difference. So thinking that there is no change in the charge, of course charge will not change, but it is wrong to say potential difference will remain constant. But if we assume potential difference this 4 volt to remain constant, then you can see that this is potential difference 4 volt, and here, so basically 4 car drop and 10 car rise. So basically if you can see, potential difference across this 30 ohm will come out to be 6 volts, and a 30 ohm के cross potential difference will come out to be 6 volts, and there is no charge on this C2, and hence we can say that 6 by 30 is zero point 0.2. So zero point 0.2 ampere will be the current in this. Of course this is right if we assume potential difference across PQ to be constant, which is not right. Why potential difference across PQ will not be constant? Because of course it is wrong to say that current here will be 0. If current here remains 0, then only potential difference across PQ would have remained 4. But here current will not be 0. The moment you close this switch, there will be again flow of charges, and current here will not be 0. Therefore, it is wrong to say that. So what is the actual value of the current? Now, let's see how to find the actual value of the current. Okay. So, so basically, when we close this, charges instantaneously is not going to change. So we can think of this as a battery of 4 volt. So I will redraw this circuit. Let me instead redraw this circuit in the next page. So this capacitor will become a battery of 4 volt, right? This is a resistor of 70 ohm resistor. Okay, and this will become this is a chargeless capacitor. So basically we will treat it like a 0 volt battery, and 30 ohm and 10 volt. Okay, so basically this is a 30 ohm resistor and 10 volt, right? Here we have got half volt battery, because the charge was 40 and the capacitance was 80. So 40 by 80 is half volt, and this plate is positive charged. So basically we can say that we will create a battery like this, which will be of 0.5 volt. Okay, and this is 5 volt battery, and this is 30 ohm. Okay, this is 5 volt, right? Now this is 40 by 80 again. So basically this will be a half volt battery, and the bottom plate will be positively charged, right? So basically we can treat it like a half volt battery again. Okay, and this is 100 ohms. So I have replaced each capacitor by a battery at t equals to 0, equivalent battery. Now if you see this part of the, and we have to find the current here. This was 10 volt in my opinion. Yes, 10 volt. Now this part of the circuit can be straight away made this point 4, this point 0.5, point 0.5 and 5 eventually will become 4, and 130 will become 130. Okay, so basically what I'm going to do, I'm going to make it as one. Let me write it here only. So this is 4 volt, this is 70, this is 30, this is 10. This eventually becomes 4 effectively. and we have a single resistor of 130. So eventually we have to find the current in this circuit, which of course I believe all of us can do very simply. We have to find the current flowing here. So you can use loop law, you can do any possible method. So I will apply nodal analysis. I will assume potential to be 0 over here. So potential here will be 10 volts. So here potential will be x volts. Okay, here potential will be x minus 4 because we are going for a drop, and here potential will also be x minus 4. So if you apply nodal analysis at this point, so what are we going to write? X minus 4 minus 0 by 70. Okay, and what will be the current flowing here? X minus 10 by 30. Then here it will be x minus 4 minus 0 by 130. This will be 0. So from here you can see that 0 will be gone. The LCM will come out to be how much? Uh, LCM will come out to be 13 theta 39 or 7 theta 21. 21 into 13. Or let me 13 sevens are 91. 13 six are 70. 91 into 3 is 273 in my opinion, right? 91 into 3. 927, yes. And so this will become 39x minus 39 into 4. So that will become 156. Okay, 39 into 4. And this is 37, 91, 91x minus 910. Okay, and this will become 70. I'm writing the, over here. So 21x minus 21 4 ja 84 equals to 0. Okay, this will be equals to 0, right? So what do we get? 21 plus 39 is 60. 60 plus 90, this is 151x. Okay, and this becomes 160 plus 80 is 240. 240 and this 160, 160 plus 280 is 240. 240 and 910 will become 1150, right? 900, 900, yes, this. So x is basically 1150 divided by 151. Now you can write the current over here. 1150 minus 10 upon 30. So this is the current which we wanted. 1150 by 151 minus 10 divided by 30. Divided by 30. So 0, 0, 0 will be gone. This will become 115 minus 151 divided by 151 into 3. Negative sign shows that, so I have assumed this to be, positive. Like I have written this minus this. That means current, that means this is at higher volt. Nah? So that means current will be going in the upward direction. Current will be going in the upward direction. Value will be how much? This is 35, 36, right? Minus sign just shows that current will be going in the upward direction. Is 150 into 3, so 3 in 12 ja. So this is minus 12 upon 151. Okay, this is the value of the current, which of course does not match with the given option. So this is the value of the current. So I hope you would have enjoyed the solution. I hope you would have understood. Thank you.